Hello. So now let's talk about more formally about annuities. And an annuity is a cash flow series that the cash flows are uniform through time. Let's say this is years. A uniform through time is always this amount, denoted by A, annuity. This is what we call end of time period annuities. And why does it have that name? Because what characterizes end of time period annuities is that there is no cash flow at time zero. Annuities are begin being paid out one time unit later. Okay. So if we want to find out the future value of an annuity, this is the formula. 1 plus the interest rate to the power of n minus 1 divided by I. And if we want to compute the present value of an annuity, this is the formula. Okay. So again, we have four types of questions: solving for A, solving for n, solving for I, and solving for the last variable, which is either f or p. So let's say you're planning to build a family, and the moment your kid is born, you want to guarantee that that new human is going to have a good education, college. And you estimate that 18 years from now, given the inflation and the increasing cost of education, you're going to need to have, let's say, $500,000 to give to your child as a present to do college. So if this is your goal, how much do you have to invest at the end of every year in this savings account that guarantees you a fixed return, or some other kind of financial security? There's so many different names. There's a full alphabet of financial securities. So what really matters at the end is the timeline associated with that security. And one of the options presented to you is, okay, let's say there's this financial security that guarantees you a 6% return per year. And you ask, okay, so how much money do I have to give you every year in order to give my kid $500K for education 18 years from now, the day she was born? So the goal is, I want the future value upon the last annuity to be $500,000. How much A has to be? So just plug and play. The future value is $500,000. A is what I'm looking for. 1 plus the interest rate, always written in the decimal form, to the power of 18 years, that's the time unit, so the interest rate is also per year. And then on the numerator we still have the -1 divided by the interest rate. So the annuity has to be, the annual deposit has to be $16,178.27. So the question was, if I want to give my kid a $500,000 endowment for education 18 years from now, how much do I need to invest in this financial security that guarantees a locked 6% per year? The answer is $16,178.27 will have to be invested in this financial security every year in order to give this $500,000 endowment to your kid. Now let's say we want to figure out what is the present value of these $500,000, and there are two ways. One way is to use obviously the present value formula. So we found out that the annuity was 16,178.27. Okay. The future value, we imposed it to be 500,000. And now I'm asking what is the present value. Okay. So the present value of an annuity, given that the interest rate was 6% per year. So the present value of an annuity formula is given by A times 1 minus 1 plus the interest rate to the power of -n divided by the interest rate. And given that the annuity is 16,178.27 and the interest rate is 6%, the n is 18, interest rate of 6, $175,000 plus $171.89. 89 cents. So having $500,000 18 years from now, or $175,000 now, has the same value. The alternative way to figure out what will be the present value will just be using the mother of all formulas, solved for the present value. So we know that the present value is equal to the future value, 1 plus the interest rate to the power of n. Right? So I could simply push this 500,000 to times 0 and figure that out instead of using the present value of an annuity. So I knew that 500,000 was the future value, interest rate was 6, and the n was 18. So this would be exactly equal to the $175,000 we just computing using the annuity. We could have used the future value and compute the present value. Present value always means the value of these cash flows at time 0. So we figured out the annuity, we had the future value, we figured out the present value. Now what are we missing? We need to play with the number of years and the interest rate. We already did an exercise for F, another for P, another for A. So now let's say, what if the interest rate was, let's say 9% per year. If the interest rate was 9% per year, then how many years? So the question now is, I'm changing a little bit the exercise, so how many years to have F equal to 500k? So interest rate went up, therefore we expect the number of years to decrease. No need to spend so much time accumulating interest, because we are earning more interest per year. Now, so let's do the future value of an annuity formula. Plug what we want. For sake of space, let's do it here. So it's 500,000 equal to, how much is the annuity, given the interest rate of 9, and this will be to the power of n. I'm trying to figure out what the n is. Minus 1 divided by I, to the power of n. (1.9 to the power of n), given that the interest rate is 9%. So the future value of an annuity formula is given by A times 1 plus I to the power of n minus 1 divided by I. So given that we want to have $500,000 and we're paying 16,178.27 every year to this investment, given that the interest rate is 9%, how many years would it take us to get the 500,000? So the n here, the n that makes this equality hold, so this will be 15 years and 0.43. So it would take us not the full 18 years to get $500,000. Now let's do a question to solve for the interest rate. Let's say I don't have $16,000 per year. Let's say that the most I can deposit is $12,000 per year. I still want to get the 500,000, and I still want the n to be 18. I still want to have it 500,000 by my kid's 18th birthday. So how much would have to be the interest? I would need to shop around for a new financial security that would guarantee me how much per year, so that this 12,000 would turn into 500,000 18 years from now. Okay, 12,000 per year, annuity, right? Regular payment. Now, since we're talking about annuities, If this was $12,000 per month, we still would call it an annuity. Because annuity is not because it's annual. Annuity, the definition is a constant uniform cash flow per time unit. The time unit is whatever. So if we have a monthly payment that is always the same, we will still call it an annuity. If we have a quarterly payment that is always the same, we'll still call it an annuity. Just stressing out that annuity does not necessarily implies that it has to be annual payments. The only thing that the word annuity implies in finance is that we are talking about a constant cash flow of a certain amount. So the question was, I still want to have $500,000 in the future. I'm only willing to invest $12,000 per year over the next 18 years. So how much would I have to earn per year in order to achieve my goal? So the future value of an annuity formula plug what you want. So I want $500,000 in the future. I want an annuity of just $12,000. Interest rate, that's what I'm trying to figure out. I want this to go for 18 years. Minus 1 here and divided by the interest rate. Using the solver, the interest rate that makes this equality hold is 0.0909. The same is to say 9.09% per year. So these are the types of questions you may be asked.